In class, we've been working on muscle cells, so I made a model of the sarcomere and all of its parts, and I'm going to explain exactly what happens for muscle contraction, and I'm also going to explain why the phenomenon known as rigor mortis occurs. So really quickly, this would be a muscle cell. Inside each one of these sticks would be thousands of sarcomeres, which would be this entire model. These blue lines indicate the sarcomatic reticulum. I'm pretty sure I said that wrong, but it holds these together. Like, it holds these sticks containing these muscle cells all together. Now I'm going to talk about how muscle contraction starts. It starts up here at the neuromuscular junction. Electrical signals from the brain meet up here, and they come through the entire, what you would call muscle cell, the sarcomere, and it causes it to contract. What really causes it to contract is these myosin, I think I'm saying that right, which is the thick cells in the middle. This is like the midline. These myosin are attached to myosin heads all over it. I only did it sideways because it's basically like a crosscut 2D model instead of a 3D one that's all over the place. And they are attached to these blue lines called actin. Basically, what needs to happen is these myosin heads, sorry if I'm zooming in too much, these myosin heads, indicated by these red pommels, will attach to the actin, attach to the filaments, and it will drag it across towards the midline. That's the sliding motion, and that's these blue parts. The actin is basically the muscle, and that's how it gets smaller when it contracts. Now the way that happens is it'll calcium will be built in. It'll keep building in and out. You know, this green would simulate calcium. It would just keep building inside the muscle cell. It will just keep building, and eventually, once it receives a signal, let's just say that this is a signal. It'll go through the transmitter. It'll go through the reticulum, which is also indicated by this, the pink line. It'll go through. It'll activate. And since the myosin senses a change in charge, these calcium ions will rush into the muscle cell. They'll rush right in there, right into the muscle cell. And when they do this, it will cause the muscle cell to contract, and it'll have these myosin heads attached to the actin. Inside the actin is troponin and trypomycin. The trypomycin is these lines. This holds the actin together, the actin filaments, and like this whole thing would be the actin filament. And these lines, these multicolored lines, the darker blue would hold together the lighter blue. I did it on these three because that's what I had, but I didn't have it for the rest of these, but I'm sure you get the point. Anyway, they attach, and what they do is they attach to the actin, and then they slide across towards the midline. Let's see if I can try to move it right now. Sorry, it's having some adjustment issues. So it would attach. It would attach right to there, and it would pull the muscle towards the midline, making the muscle shorter. Right here. Let me try and move it now. We'll pull the muscle towards it, taking the troponin with it, sliding it across, using a combination of ADP, which is basically the chemical for equation. No, it's chemical for equation, chemical for energy. It'll slide across, making the muscle even smaller as it continues sliding. That just popped off, but it doesn't matter. Yep. It'll make the muscle smaller. After that, after the muscle has been smaller and it's contracted the way that it was supposed to, ATP, which is indicated by these, will go to the heads, So it'll be like, let's just say it's up here from the normal myosin. It'll slide down to the head, and when it gets to the head knows to let go. So the head will come off. I just glued it to the actin because it would be easier, but this one's loose. So instead of being attached, the head will come off, stop being attached to the actin, and since it's ATP, as it stops being attached, it'll break down back to ADP, and then it will attach again and then contract once more. Now, the phenomenon known as rigor mortis, which is basically the stiffness that muscles feel and are subjected to prior to death, close to death, it starts around these calcium. For muscle contractions to work, you need to have ADP, ATP, and you need to have calcium ions to work. What will happen is the calcium ions will be pumping, they'll be working, and if a person were to die, the calcium ions, instead of being able to rush in, they would stop. They wouldn't be able to get inside the mycelium anymore, and there would be no stimulation. These heads wouldn't attach to actin, and they'd be continued to stay they would attach, my bad. They would stay latched onto the actin. They would pull it towards the midline, again, the M line, and they would stay like that because these calcium ions are no longer in the mycelium to boot up a reaction that causes the ATP to basically come back. So that's how it works, and yeah, pretty much.